Recording is on. 2-6 combinations of functions. Okay, if you are following along using the PowerPoint, you are going to notice that I don't go nearly all the way through 2-6. We're only covering a part of 2-6 now. If you're following along with the screen, this is what we're doing. We're only going to talk about 4 things with functions. I can add 2 functions together, I can subtract functions, I can multiply functions, and I can divide functions. Okay, so those are the 4 things that we're going to do. We're not going to worry about plugging functions into functions. That's another part of 2-6. So basically what we're doing now is 2.6a, and we'll do 2.6b later. Okay. Functions, yeah, but we won't worry about that until after the next test. COVID part 2, no school after spring break. No, I'm just kidding. Right, that's what I'm saying. Right. Yeah. Okay, so arithmetic combinations functions. So I can take 2 numbers and combine them. I can take 2 numbers and multiply them. I can take 2 numbers and add them, subtract them, multiply, divide, right? And I can do the same thing with functions. For example, if I have the function f of x equals 2x minus 3, that is a function. It's a line, correct? I also have a function g of x is equal to x squared minus 1. That's a function. This is a parabola. If I wanted to add those 2 functions together, all we're going to do is combine like terms. Okay, so f of x plus g of x would be, well, here's f of x, which is 2x minus 3. It's in parentheses, plus g of x, also in parentheses, x squared minus 1. I'm adding 2 functions together. So how much purpose do those parentheses actually play? Yeah, when you're adding, they don't really do anything, right? So combining like terms, starting with the highest degree. We always want to do this in descending order, always in general form, okay? The highest power is x squared. So I have a positive x squared. I have 1 2x term. There's no other x term. So I have plus 2x. And then I have a negative 3 plus a negative 1, which gives me the negative 4. Okay. So f of x plus g of x is equal to x squared plus 2x minus 4. That's all there is to that. Okay. Did you have a question? Okay. Difference, same thing. Take one of the functions minus the other function. Put them in parentheses. Now subtracting, are those parentheses important? Very important. Very, very, very important. If I have f of x minus g of x, I'm subtracting the entire g function. So the g function must be in parentheses because that negative sign is going to be distributed. Combining like terms, starting with the highest degree, I have a negative x squared. That's a positive 2x. And then I have a negative 3 minus negative 1. Negative 3 minus negative 1 would be negative 3 plus 1, negative 2. Yes, ma'am.
Since you're distributing the negative minus sign,
yes,
would it not change to negative 3 minus negative 1?
No, it's negative 3 minus negative 1, which would be a negative 3 plus 1. If I am multiplying 2 functions together, in this case, it's just a binomial times a binomial, right? So with the binomial times a binomial, what are we going to do? FOIL, right? So if you'll notice, first times first, and I kind of walk through what's going on here. When they did first times first, nice. No, undo that. Okay. You go away. So first times first, 2x times x squared is 2x cubed. Okay, that's first times first. If we're foiling this, next would be outside times outside, right? Outside times outside would be 2x times negative 1, which is, they wrote it down here. And the reason they did that is because inside times inside is negative 3x squared, which is a higher degree than the negative 2x. So they flipped them. Is that okay? All right. And then, of course, finally, we have last times last, which gives us a +3. Here's a situation where we FOILed two binomials and had no like terms, so nothing combined. Quotient means divide. F of x divided by g of x. Well, f of x is 2x minus 3 divided by g of x, which is x squared minus 1. You can't divide by 0. So because I have a variable in the denominator, I must specify, hey, here's the answer. However, x squared minus 1 factors, right? Factors into x plus 1 times x minus 1. So the two values of x that would make the denominator 0 would be -1 and +1. So that's why we're making the statement here. So here it is. This is f of x divided by g of x, but x cannot be plus or minus 1. That is part of the answer, and it's very important. Okay? Questions so far? The domain. If I take two functions and put them together, the domain is going to be all of the f domain and all the g domain if they overlap. Okay? If I have some numbers that are not part of the f domain, then it cannot be a part of the combination domain. And that's what this is saying right here. Anything that they haven't, if the domains are in common, anything they have in common, that's the domain. Exception, dividing. As soon as you divide, the denominator can't be 0. So find the values of x that make the bottom 0 and restrict that. When we write these, we're not going to write f of x plus g of x. Okay, instead of writing f of x plus g of x, we're going to write it as f plus g of x. Folks, this is not multiplying. This is not the two functions times x. That's not what this is. This is take the f function and the g function, add them together in terms of x. You see the difference? Okay, so again, this writing it as f plus g of x is the same thing as f of x plus g of x. Just a little more concise. Same thing with subtracting. This is f minus g of x. Multiplying. This is f times g of x instead of f of x times g of x. And then dividing. This is f divided by g of x. And again, g of x can't be 0. Still redundant? Okay. I have two functions here. I have an f function and a g function. And the question says, find f plus g of x. Then evaluate the sum when x is 3. So we have two steps here. Step number 1 is what is f plus g of x? So the f function is 2x plus 1 plus the g function x squared plus 2x minus 1. Okay, so x squared, then we have 2x plus 2x gives us plus 4x. Then we have plus 1 minus 1, which is, okay, so f plus g of x is equal to x squared plus 4x. Now, I'm going to write this down the way you're likely to see it go into the future. To evaluate this when x is 3, what I'm asking you is this. I don't want to know what f plus g of x is. I want to know what f plus g of 3 is. which just means take the f plus g function and plug in the 3, right? 3 squared plus 4 times 3, 9 plus 4, 21. I wanted to go ahead and do that for Jacob because he would have, taken his shoes off and found out he still didn't have enough digits to get to 21. Used your nose as as that last number. I thought you were going to say, joke's on you, my right foot has 6 toes. All right, and folks, that's really the end of that section. Okay, I have a few practice problems that I'll work through. If you want to start working on the homework, awesome. But I'll work on these practice problems real quick. So number 1, evaluate f plus g of x at -6. So f plus g of x, highest exponent. So I'm adding these two together, right? X squared plus x plus 1. So now to determine f plus g of -6, -36 minus 6 plus 1. Okay. Number 2, it wants to know what fg of 8 is. So I need to figure out what fg of x is. I'm going to go and write this out. We have x plus 3 times x squared minus 2. Okay, first times first is x cubed. Outside times outside would be -2x, but inside times inside would be, so I'm going to write the plus 3x squared down first. And then I have my -2x for my outside times outside, right? And then last times last. Okay. So now fg of 8 is 8 cubed. Nice. Which is 512, I think. Plus 3 times 8 squared, which is like 192 or something like that. Huh? So all I've done right now is plugged everything in. Okay. And then clickety click click, type that in your calculator and press enter, right? Is it 600 something? What's the answer? $670? I don't know. 682? Do I get a second opinion? Eight cubed plus 3 times 8 squared minus, 682. Okay. Okay. There's, I think, one more problem, but it has like 5 parts, just like your homework. Okay. So this one says find f plus g of x. So add those together, I get x squared plus 2x minus 15. Y'all good with that? Those that are paying attention to this. If you're not, that's cool. If you're working on your homework, that's fine. F minus G. I do want to mention to make sure you're paying attention to the order, because F minus G of X and G minus F of X are not the same. Okay. So F minus G would give me a negative X squared as my highest degree, plus 2X. And then 1 minus negative 16 would be.
Wait, but I can see the
I did.
Oh.
Yeah, I said 1 minus negative 16 would be 1 plus 7. 1, yeah. Part C. Yeah, let me go write this down. Yeah, it will be. Okay. So 2x cubed. First one's first. Negative 32x is outside times outside. Inside times inside. Plus x squared. Now let's go back to the outside times outside, which is minus 32x. And last times last. Okay. Part D is asking for f divided by, or g of x. The f function is 2x plus 1 divided by the g function, which is x squared minus 16. When you use the domain, it's going to write it in interval notation. We'll do that in a second.
Okay.
Okay. So this bottom factors, right, into x plus 4 and x minus 4. Sit down, please. Some people behind you are watching. Thank you. Okay, so this tells me, and we're kind of answering E right now. On the homework, I think this is the answer for just f divided by g, and you don't talk about the domain, correct?
Well,
but that's the next piece of it, right? So for the first piece, this would be the answer. Okay. I don't like leaving it like this. I want to go ahead and make the statement, since I'm writing it out, that x cannot be plus or minus 4. But when you're doing the homework, it says to enter in interval notation. Okay, so part E for this one. And I'll scroll back up in a minute for screenshot in just a second. So part E is, what is the domain in interval notation? Well, x can be anything except for these two numbers. So it goes from negative infinity to negative 4 union negative 4 to 4 union 4 to infinity. She's not here. Okay. And I think on the homework, you actually use the union symbols, correct? Okay. All right, so let me scroll back up for this. And folks, that does in fact complete 2-6. So tomorrow is just a day to work, correct, on these assignments? Also, it's probably a good idea to get these kind of knocked out and be working on the review, because the review is going to be due on Tuesday. So don't wait until last minute. Okay. So we'll be working in class on the review on Monday, test on Tuesday. And then we have 3 sections to cover Wednesday, Thursday, Friday next week. Okay. Questions, comments, complaints? Don't want to hear them. Concerns? Don't care about those either. Cares? Why?